together and improve the ways that data and information is delivered to the internet, and to try to demonstrate through some examples like I'll show tonight around what we can start to do with this information if we deliver it the right way. Initially, then I'll talk a little bit about a couple of larger projects. Initially, the Terrestrial Ecosystem Research Network, which people may or may not know about. And TURN is a nationally funded project which sits under alongside a range of other research infrastructure activities, and these are big projects which are out there collecting new data and information at the national scale. It's big cranes over rainforests, and it's millions of dollars worth of moorings out of the Southern Ocean, and these kind of big systems. And in the initial stage, coasts were kind of left out. There's this big terrestrial focus under TURN, and there's a big marine focus under an initiative called IMOS. And coasts kind of slipped through the cracks a little bit. And ultimately, TURN started to realise that there was real opportunity in coastal space, not so much about big infrastructure and monitoring new systems, because there's lots of us out there collecting data. There's councils, there's state governments, there's research organisations, there's universities, there's lots and lots of data. So what the opportunity was to start to combine some of that information. So TURN at a high level is made up of a number of facilities, and there's groups that are focusing on soils or flux towers and all sorts of bits and pieces, and if anyone's interested in any of those particular domains, there's a lot of information on the TURN website, and there's groups around the country working on those. And the Australian Coastal Ecosystems facility, which we run through CSIRO, focuses on the coastal space. So TURN is all about everything from the instruments and sensors all the way through to developing standardised methods for data collection. There's a heavy focus on data curation and publishing, and this has been a big space, especially in the research community, that has been a bit lacking in the past, and the CSIRO is one of the worst at it, getting data out and making it available. And we're trying to turn that around a little bit. And one of the opportunities there is around getting attribution for data and getting licensing on data. And there's a big push for open data and Creative Commons, and etc. So, and TURN has been pushing that into the research space for quite a while. But it's all about trying to get data in, using the right standards, getting data into the right formats and out into national and international systems so that you can go to Google and start to search for data and find it and actually get access to it and use it. Lots and lots and lots of organisations involved at both local levels, university levels, state, federal and international as well. So at the coastal level, as I said, really the focus was about not going and collecting huge amounts of new data, but trying to work out how we can build on communities of practice and start to help people to get their data up into some of this national infrastructure. There's been in the order of $1 billion spent on computing infrastructure and storage systems and big systems that are there basically free to put your data on and make it accessible at the national level. There's some huge projects that a lot of groups at the state and local level have an idea of because it's got this research stamp on it. But through TURN, we're trying to get more people able to contribute to some of these systems. So we're trying to work down into individual coastal data providers. Initially, we started at the state level and talking to state agencies around the country about water quality data and coastal habitat data. And we're now starting to talk a lot more with councils. Initially, we've been working through groups like the Sea Change Task Force and other kind of regional initiatives of amalgamations of councils, and through conferences like the Coastal Councils Conference, we've had really good traction. But basically, we're able to host and publish data sets through TURN and start to connect these up into the national systems. And initially, we're focusing really, the big two focus areas are around water quality and coastal habitats. And we need to get to a point where anyone can go and find out what water quality monitoring is done in an really hard to find out what's done, where, and who does it. To get a national picture of that at the moment. So that's the sort of thing we're trying to pull together. So the Coastal Ecosystems Facility, or ASEF, we've got a range of websites, portals, servers, infrastructure, systems that we can actually host some of this data and make it accessible. As well as start to provide the metadata and project information about this information. And we're going about trying to acquire things like satellite imagery and information about water quality sensors and what you can use and how you can make use of it. And the idea is to make all of this freely available. So stepping down one more level, a project that was originally funded through one of these big national initiatives, the Australian National Data Service, was about starting to develop some of these systems and services to help make this happen. So this is a project called Secretor, which was really starting to pull together modelling data and monitoring data and geospatial data in the right technical way, in the right services and systems to make it so that we can combine it into something that we could value add. And of course, everyone comes up with a portal. And there's lots of these out there, and you can go and find specific portals about pretty much anything. And that was a bit of an add-on initially, just to getting the data in the right structure. But we wanted to kind of take this a little bit further and start to look at where we could really go with visualization. So this was a basic portal that let us look at model data, interact with it, and discover some of the information. Look at the HMP sites, the monitoring program in South East Queensland, and start to play with the time slider, etc., and just look around at some of the data and graph it over time. This was some real-time data combined with the HMP data, and look at some of the patterns in water quality. And there's a lot of technical work. That's what I need to get out of that slide. Lots of services, web services, getting data into the right structures and formats and systems, etc. So that was what a lot of the work was getting the background systems in place. And as I said, this was funded by ANZ, so I'm contractually obliged to put the slide up. But the important thing to know here is that a lot of people in this room might not know about ANZ. And ANZ is about trying to get data up at the national level. It's federally funded, and they run a thing called Research Data Australia, and ultimately this is where a lot of the data sets, monitoring and research data in a really broad sense, and a lot of what councils and state governments collect is actually research data, and can be used a lot more broadly. And it's meant to be a discovery point for a lot of Australia's data sets. So it's just worth flagging that these sort of organisations exist. But what enables all of this is data access. So how we're used to working at the moment is that we email someone, we find something on a website, we download it, we might copy and paste the table off the website, and we'll get it in an Excel file or an HTML table or something, a web table. And we try and do stuff with it on our desktops, and we play around with data. Where we're getting to is things around web services and linked urban data, which is an emerging movement around the world at the moment. But web services have got a bit of an identity crisis, because they look like this. There's these horrible piles of XML data that none of us really identify as data. We know what to do with an Excel file, we don't know what to do with that. So we need to work out what web services really mean and how we make use of them. But we use them all every day. Probably most people in the room use Microsoft Outlook or Exchange server to deliver your corporate email. Essentially, that's a web service, delivering your email to your computer, pretty much any operating system you want, any platform you want, tablet, phone, etc., any browser you want, and you don't have to think about it nowadays. It's just kind of delivered to everything. What's pushing all that information is a web service sitting on the server that your IT department runs. We need to start thinking, instead of our CSV file that we downloaded off the internet, we need to start thinking about web services for data. So if we start to do this, we can then push data to, and we need to make sure that we're delivering it to the right standards. And one standard is Open Geospatial Consortium, defines a lot of the geospatial standards. But we need to, if we do this, we can then start to make maps and graphs and systems in pretty much any browser we want, on any platform, in any computer, or down into statistical software or mapping systems, or we can push it off into pretty much any workflow or model and reuse it in other processes as well. So it's web services that will start to allow us to get the data in the formats we want, including Excel and CSVs, but we can also start to reuse it in lots of interesting systems. So the Logan project is an example of using web services to start to show what can be done with data coming from different places. And there's a few data sets in there from a range of organisations. It's still very much in development, but I will give it a go and see if I can do a live demo. So, if I can find, just refresh it. So the concept of this was really trying to bring data and information into a basic Google Maps style mapping interface to tell a story, and the story that was chosen was around floods. So what's happening here is we've got a whole heap of sites and bits and pieces being loaded onto the map in real time, and we've got some more static information. So we can come in and start to say have a look at the 1887 flood and find out some descriptive information about that flood, and we get a few markers on the map that start to tell us that these are, for example, these are flood heights that were recorded in 1887 that tells us that at the McLean Bridge station, the river height reached 22.3 metres and the major flood height was 16 metres. So it's a pretty substantial flood, which hits a particular category. And we can have a look around at the extent of this flood. But there's lots of other information out there as well, like historical photos. And we can start to actually make use of these historical photos and find out that, okay, the major bridge in the Logan River was washed away in the 1887 flood. And this is some of that contextual information that we really don't make use of very well at the moment. We can travel through time and have a look at the 1947 flood, and we get a different collection of flood markers, 1974. As we go through time, we can find out how different floods impacted in different ways around catchment. As we get later on, we start to get more and more information and more interesting information. So as we get to 2008 onwards, we start to get a lot of monthly monitoring sites, and ultimately once we get to 2013, we start to get some much more powerful information like modelling. So in this instance, we now start to get we've got some of these dark orange markers here, which are real-time stations, and we can come in and have a look at salinity, for example, and this is running effectively. The logger turns off at 5 o'clock each day on this station, but this was 5 o'clock tonight, and this is salinity in the Logan River. So this is real-time data coming directly from some automated stations out in the Logan, and we can say, go and show me the last 3 years' worth of salinity data directly from that station, and that then loads. We can then come and have a look at a nearby monthly monitoring station and say, I'm then interested in a similar parameter. Salinity. And this will then load the monthly data, which hopefully you can just see, which is a much, obviously less data here, but you can see in the green in the background there's the monthly data, which then plummets around this flood in 2013. So we can zoom in and start to have a look at what happened in early 2013, and ultimately we can start to combine other data sets such as gauging stations. This is then the actual flow data for this period. Let's put this on a second axis. When we start to look at this, was the actual flood event, the big spike in river flow, a big drop in salinity, and actually this event took a really long time to recover from the flood, and salinity stayed quite low for a really extended period. But we can also start to have a look at what happened from a modelling perspective. And this was the day of the flood, and we can start to see the big change in salinity, and you can't quite see the scale. The scale's just off to the side of the wrong units. We'll forget that. And as we progress through time, we can get a different slice out of the model. And this is, model data is really hard to use, but because this is stored in the right way, presented in the right standards, and used the right web services, this is actually coming directly from a server, straight from our models. They throw the data on the server, and this just interprets it and presents it. As data gets added to this every day, it gets presented. So we can look through this and we start to see that there was actually a plume of water pushed to the north with the southerly flow as the weather moved around after the flood, and we start to get photos come up on beaches on Australia of huge piles of rubbish and pumice and all sorts of building up on beaches. So this is sort of information that we can start to combine and start to tell much more of a story around anything. This is floods, but we can start to combine lots of different data sets in different ways to really tell a story and tell a narrative. And Logan Council's particularly interested in this sort of information. They've got lots of photos around their catchment that are being geotagged, and really for them it's about building community resilience and community understanding around, well, okay, this bridge was washed away in the past, and this is where the flood went to, and this is what happened, and starting to build that understanding, and it's not comfort, but it's